Today, what did you do today? Today, you guys learned about Portainer and Docker and all of that stuff and got access to secure chat, right? Like that's kind of what you did. Okay, good. So today's session, probably I would say not much practical, but very theoretical, but probably the most important session that you're going to do during this internship. Okay. This is the foundation of how we want to do work. And it is very important to embrace this and extend this and follow this, because this is what will determine whether you're an engineer or you're a coder. And if you're a coder, you have no future, pretty much neither here nor anywhere else. Future of coding is gone, but an engineer, an architect does have a future. So we are going to talk about AI SDLC. Let me bring up my presentation so that I can share my screen. So don't drive. So today is about process, and so it's very important to learn this process. Remember, I told you I will accept almost anything that you do, but I will not accept a process not being followed. So you have been doing some of the processes with Git and other things, but this is about the whole software development process itself, right? SDLC has always been there. There is nothing. SDLC is not a new term, right? Software development lifecycle, and you learn about it. How is it important in the case of AI? We'll talk about it, and then we'll talk about what is the SDLC we want to follow. So before we start, what's an SDLC? Who's going to tell me what's an SDLC and what does it mean? Let's start with that. Yeah, go ahead, Ishan.
It's the software development life cycle, which kind of tells us how exactly should we follow the process of software development in a controlled manner and uniform way.
Okay. Who's going to tell me, next question, who is going to tell me the steps of an SDLC? One step from everyone. So raise your hands and we'll go with that. Yes, Khyati.
First step is the analyzing the problem statement, what we are gonna solve.
Okay. Next.
Requirement collection.
Okay.
Requirement
Next.
collection.
Next is
system design.
System design. Okay. Next, Ishan.
Development.
Okay. Some SDLCs do have that. Okay. What else?
Testing the model.
Okay. Testing. What else? So everybody else has not studied SDLC. Yes, Gravit.
Feedback.
Okay. Feedback. User acceptance, UAT. We can call it UAT, user acceptance testing. Feedback. Okay. Rishika.
Deployment.
Deployment. Okay. What else? Anything else? Okay, you covered a lot of these things, but I'm not sure whether that's the order I would do it in, kind of thing. So let's talk about it, and let's talk about, like, there's nothing wrong in what you said. Most of it is correct. I find it not very effective to follow it in the order that you did, and so we're going to talk about what we actually want to follow, right? So why is SDLC important? You guys mentioned it is important because it provides structure and portability. What does portability means? Meaning that once we have a process, it doesn't matter who is working on it. Everybody can work on it. One person develops, other person can maintain it. One person leaves, somebody else joins. They can start over it because there's a structure, there's a way, there's a defined mechanism. Once you teach the mechanism, everybody can follow that process, kind of thing, and make it happen, right? It allows you to maintain things easily, because part of software development lifecycle, as somebody said, system design, for example, right? So system design is documenting the system, and that allows you to maintain the system easily by looking at what are the pieces out there, understand it, and since you're following in a structured fashion, it makes it easier for people to understand what happened, how did it happen, how do we fix it. It also makes it reproducible. So that means that if you follow the same steps over again, you will get the same results. And that's one of the biggest challenge with AI, kind of thing, that with vibe coding. A lot of people criticize vibe coding. The problem is not in the criticism of vibe coding. The problem is that if you follow vibe coding without an SDLC, it is a problem because it is not reproducible. But with SDLC, even vibe coding can become reproducible. Tomorrow, you are going to take a class where you're going to be taught how to develop a whole front-end application using vibe coding, using Google AI Studio, and then you will bring it into the SDLC process. So you're going to learn that process. But the key problem here is not the vibe coding, but how you apply vibe coding. And it doesn't matter whatever tool you use, as long as the process is correct, it can be leveraged, it can be scaled out, kind of thing. Following an SDLC also reduces the time to market, and time to market is important because in the past, people could develop projects in a year. It was considered good. Before that, 10 years, it was considered good. In the world of AI, typical turnaround time, people are producing products in day, month, week, or even a day, right? So that means that the time to market is very important. Why? Because if you look at it, there are billions of people in the world. There is definitely someone else in the world who has the same idea as you, right? So if you do not go to the market first and produce something first and sell it first, somebody else is likely to go ahead and do it first and get it to the market first, right? And with the tools that are available, you guys are equally powerful. Anybody can do it. The first person to use the right tools to get it to the market wins, right? First person in the market. So time to market is very important, and allowing an SDLC allows us to reduce the time to market and get it in a structured manner out, right? The last part, which is very, very, very important, is that an SDLC provides visibility. A proper SDLC provides visibility. A incorrect SDLC does not provide visibility. For example, many of you said, okay, we're going to write requirements. We are going to do system design. We are going to write code. We are going to test it out. We are going to get feedback. And then somebody said, we're going to do deployment, right? So think about it, right? At what point of time will it be visible? Will it be visible when you have written requirements? Will the product be visible? Anybody? During system design, will the product be visible?
No.
During
No.
during coding, will the product be visible?
No.
During testing, will it be visible? Maybe
No.
little bit feedback.
Yes.
So that point is that you are starting the project, but the visibility is very late in the game, right? And the one step, and if you adopt the correct SDLC, the visibility will be provided upfront, and then that will change the whole perception, kind of thing, right? I can talk about a lot of things, but if I can show you something, you will always appreciate that more. People appreciate what they can see, feel, touch. Every human being, like, doesn't matter what it is, any person, they can feel something, touch something, or feel something, then they will appreciate it more. If you just explain to someone, they can try to imagine, but they will not get the gratification from something that they can see, feel, touch, right? So if you want to be good engineers, you always want to work in an SDLC which provides not only you, but the end user of the product a part of the process by giving them the ability to see, feel, touch. And I say see, feel, touch because, for example, if you're doing software, we want to see. If we are doing, say, things like AI voice products, we want to feel our sense of hearing. We are hearing AI. If we are using products like Alexa, we want to use. So all of the senses are important. The idea is that the moment the customer feels the product, the whole perception changes, right? So visibility is very, very, very important, and it is one of the key differences which makes you a very in-demand successful engineer versus an code. Okay. Is there somebody else? Somebody else is late. Who is okay? Vaishnavi. Okay. So next, let's go to the next slide. Okay. So if I have to build something, and I think this is what you guys said, we are going to build something. Vaishnavi, why are we late in the meeting, please?
Sorry, I thought the time was 8:15.
Okay, so Vaishnavi, there is a calendar tool. You guys have to follow it like everybody else is on time. It is very unprofessional for people to be late in a meeting. I do not appreciate it. And I do not like people to be unprofessional in their working environment. Okay, I do not want to call this again, guys. So please be on time. 1 minute is the maximum time allowed to be late in a meeting. Okay. Okay. So you guys said development process. Somebody said develop front end, develop. I have to develop an API, write a database, build authentication, connect front end, connect API to DB, hard coded configuration. What is the problem with it? Like I'm sure you guys have developed some projects in your college. You have done all of this stuff. Yes, no, maybe, right?
Yes.
Yes.
So
Yes, sir.
is this wrong, right? Like I've broken it down into steps, right, wrong?
Yeah.
Yeah, it's
Yeah,
right.
the hard-coded configurations, it should be in environment.
Okay, hard-coded configuration is a problem. What else? Everything else good other than hard-coded configuration?
There are no testing pipelines over here.
Okay, no testing there. What else? Everything else good. So no testing, hard-coded environment variable. Those are the only two problems I see.
The process itself is unstructured.
Yes.
What does that mean?
By not following proper, I mean, the planning should be at the very beginning. Then there should be designing and development.
Okay, why would the planning and designing change how I build it? Like, wouldn't I do the same thing? I would still develop the front end. I would still develop the API. I'd still write the database. I would build the authentication, connect the front end to the data API to the database, API to database, whatever it is. I'm going to do exactly the same way. So how will planning and design make this different?
The code will crash because when we connect to API and DB, the front end will affect and the other database will affect, so
Why?
that it will crash.
Why? Why? That's just a statement. Like, why?
Because the connection between front end and API is missing.
Okay, I will correct. There's a typo. I will connect the front end where it says connect front end to DB. I will say connect front end to API. API to DB is there. So there's a typo in there. That should not have said DB. It should have said API. In this box, it should have said connect front end to API. Here it says connect API to DB. So I have connected all the right pieces. So I got my application. What's wrong? Come on, you've engineering studies. You should tell me what's wrong. What could go wrong? Why do we need system planning and design? I could do this, and this will work.
Because
This plan might not.
Go ahead. One at raise your hands. Always raise your hands so that you go in the order of this thing, get into the structure. Yes, Khyati.
Yeah, so we need system design because if we like if there's an error at any point, so we need to know when the error occurred, after which process, or how we did it for future references. For like, let's suppose we have to build a similar application in future. So we need to know how we are gonna do it. So if we already have the full system design, it won't take much time for us to build another similar project, or if there's an error in future and we want to do some change, so we need to know how everything happened so we can do the change in the particular code file or particular document.
Maybe not. What else? So Ishan, go ahead.
If we plan the system beforehand, then it would be easier for us to, as Khyati said, it would be easier for us to implement, because when we are planning, when we are in the planning stage, then we sort of map out the things which we are not able to see in the execution phase. During the
yes and no. Like so I will tell you guys, some of you guys, like, first of all, do not use words which are meaningless. I'll tell you what's meaningless word. Okay, if I go to a restaurant and somebody serves me food, right? Food is amazing. Is that a meaningful statement or a meaningless statement? Come on. Is that a meaningful statement, meaningless statement? You go to the restaurant, top restaurant, 5-star restaurant, Bukhara Grill in Maurya Sheraton in Delhi, and you order their best dal makhani and big naan, basically. Tastes delicious. You say it's amazing. Is that a good description, bad description, meaningless description?
Bad description.
Why?
It
Because
lacks details.
Because why?
because we need some details, and another thing is it's already a top restaurant and very famous and all top notch, so it's obviously
So let me stop you guys. Some of you guys are good at communication. The people who are good at communication are very bad at talking meaningful stuff. Okay, I will tell you, right? Like, I'll tell you this. To me, if I'm eating food, right, what is meaningful is that, okay, it is a sweet dish which tasted the right amount of sweetness. It was not too sweet, not too, like, it tells you about the taste of the food, right? So, amazing, extraordinary, those words are really nice, big words, but don't tell you anything about the thing that you're doing. In the same way, when we're talking about software design, easier, less, more, these words are meaningless, right? You need to learn how to talk about design in a way that says concrete things. That this will not happen. Like, for example, the first feedback we got that, okay, hard-coded configuration is a bad thing. Very clear. Like, it is a feedback which says, okay, we can change from hard-coded to something which is environment or whatever it is, right? So it is actionable kind of thing, that feed. So when you're criticizing something, and learning to criticize is very important. And I have seen, for example, I was reading some of the feedback people have given in there. Some of those feedbacks are kind of very generic, like they don't tell you what to do. So you need to learn, like as I said, the feedback process is about learning how to give feedback. Everything that you say should have a meaningful output that, okay, this is what we will change, make this, fix this, right? Just for saying something is not good enough. Like, some people, especially people who are good at talking and who find themselves good in parties and in their company, are good at saying a lot of things, but they really do not say anything at all, kind of thing, right? Most people don't call you out. I call you out, basically, because I personally have, when I go to meetings, for example, a lot of people will spend first 10 minutes talking about the weather. Okay, I walk out in 30 seconds out of those meetings because I do not have the time to listen to the weather for 10 minutes, kind of thing, right? So when we're talking about technical stuff, start using terms which are technical, which allow you to say this is wrong, right? For example, somebody mentioned that, okay, maybe this connection of front end is not connected to API is connected to DB. That's a problem. Like, if front end is connected to DB, that's a problem, right? I would say that's a problem. We should change it from front end connected to API, right? Those are very concrete figures. Easier to debug, difficult to debug. I don't know why. Why is it easier to debug and why is it difficult to debug? Why is it easier to find a problem? Why is it difficult to find a problem? Not necessarily true. So try to find a reason which you can substantiate with a actual thing that you can change or improve in the system. Okay, we'll talk about, like all of your points are in some ways correct, and we'll talk about that, right? But in general, most of you, when you've done your projects, this is how you've done your projects in your college. Whether you criticize it right now, whether most people, when you get somebody says do this thing, you go ahead and start building it, and then you create system design and stuff. Like, most people do the design work and documentation as an afterthought versus before, right? And the part I'm trying to tell you is that that's the way coders work, right? Coders will first write code, then they will write a design which meets the code. Okay, it's an upside down process, and it will not get you very far. It is a very expensive process, because with that approach, you did all the work, then you document it, and somebody says that this is not right, let's start all over again, right? It's like, okay, I want to send a space shuttle to the moon. Let me first build the shuttle, and then we figure out that, okay, this then document what I built, and then somebody look at the, okay, how do people get into there? There is no door. Oh, now let's break everything down and build the shuttle all over again. Okay, that is the coder's way of doing things, right? Engineers never do it that way. Okay, true engineers, if you are actually an engineer, an engineering degree doesn't make you an engineer. An engineering mindset makes you an engineer, right? An engineer will first plan and design, get the design validated. Like, an engineer will be able to predict by just looking at the design whether it will work or not work, and then they will try to build, kind of thing. They do not first build, right? Second thing, so we'll look at the next step and then I'll tell you. So how would you do it as an engineer? As an engineer, you would first design, and that design also has multiple layers kind of thing, right? So the problems that will tell you in this thing, first thing, okay, we are building a 3-tier application, right? A simple picture. So an engineer's best tool for design is building pictures, because as we say, a picture can tell the story of 1,000 words, right? So it says that, okay, we are going to build 3 things. There is a front end, there is a API, and there is a database. The front end talks to the API, API talks to the database. If I drew a line from the front end to the database, I would know it is wrong from the picture, and I can tell you, don't do this, instead do that, right? So we can correct a lot of the things right from looking at the picture. So as you start working on your projects from tomorrow and all of those things, no matter how simple the project looks, right? No matter how simple the project looks, no matter how complex the project looks, you are first going to start with doing a high-level design of that. And high-level design is very simple. It has only the list of few boxes which tell these are the high-level component. It does not go into detail, right? I have dealt with engineers who come in for interview, 3 years experience, 5 years experience, and they talk about the project they did. I ask them, why don't you show me the project you built in a very simple visual way, a high-level diagram, right? And they start doing, oh, I have this class, and I have this table, and I have this API call. It goes into a level of detail. Think about it, right? In an interview, the interviewer doesn't have the understanding of your system. You're going too much into detail, they will not get. So what you need to do from an engineering perspective is that you need to layer the information in. So layer number 1 for system design is that you have a high-level design, which says, okay, we have 3 things in our system. That's it. Okay. And then you go to the next level of design, and where you break that each of these things into simpler, more detailed components. For example, for the front end, you may have a UX prototype, you may have a mock design using Photoshop or whatever visual tools you may have. You have a mock interface. There are a lot of ways to do UX design, and you would do that kind of thing, and you do that. Same way for an API. API is like a contract. It tells you that, okay, I am going to provide this information and I need this information back. So you document that contract, because the contract tells you, okay, this will work or not work. If you see the lines between a to-do web app and the to-do API, there's a line in between. That line is the contract, right? From the to-do API to the to-do database, it's a contract, right? So you document the contract, right? There is benefits to it. If all the contracts are documented, that means that 3 people can work on these 3 things independently. People can work on it independently. They can scale it out. Something which will be, instead of being done sequentially one after the other, you can do it all at once, because when this guy is developing the application, he knows that an API with a certain contract will be available. When the guy developing the API is working, he knows that a database with a certain table structure will be available. So having that specification with the API specification, or for an ERD diagram for the database, allows you to document that contract upfront so that everybody is on the same page. You also validate that, okay, will it do this? Will it not do this? When you go to an architect will say, what will happen when this happens? Oh, this will be stored here. This will be stored here. So you discuss all of that upfront. Otherwise, you build it all up and somebody says, oh, this happened. Oh, now we need to change the database. We need to change the API. We need to change the front end. The number of change becomes very heavy. Most people who take a lot of time to do work do it because of this. Because what happens is that they develop it, then they write the design, and then they find a problem and they have to go back to the top kind of thing. But if you have designed it right, you pretty much can build it in one go kind of thing. That's kind of the benefit of doing a upfront design. So in your case, you will always, in your design process, and we'll talk about requirements also, but in your design process, you will always do a high level diagram. If you are having a conversation, in most cases, you're going to review your design with me. I will be reviewing each of your design for everything that you do. You do not start your conversation by showing me code. You do not start your conversation by showing me anything other than a picture that you see in the first column. Whatever the picture may be, not this picture, but whatever the picture of the high-level diagram is. So you will say, okay, this is the high-level diagram of the project I'm working on. I am working on this particular box. this is the demo of this particular box, this is the code of this particular box, this is the business logic of this particular box, and that's kind of how you're going to talk. You're going to talk down in the layers, and I can stop you at whichever layer I want. You will not start from the bottom layer kind of thing, right? That's kind of the key thing. One of the key metrics which tells me that you're an engineer or you are a coder, right? Coders, no place in the world. Engineers, lot of place in the world. So, and that will come from, and you may be doing all of it, but sometimes we do not communicate in those layers. So whenever you're opening your mouth, the first statement you will show is a picture. Like anybody who shows me a picture first and then talks, okay, wins 100 points. Anybody who shows me anything other than a picture and talks first starts from, okay, on a scale of 1 to 10, you're going to get scored on a 2 or 1 basically. But if you start with a picture, potentially you could get a 10 basically. Okay, that's kind of how I look at it, kind of thing, that okay, if you are an architect, if you are an engineer, you'll make $100. If you are a coder, you may make $5. So you decide which job you're targeting for. Today's job difference between an architect and a coder is a $5, $100 difference basically, and you can decide which way you want to go. But start thinking about it this way. Everything that you do, everything, right? Planning, designing, detailed design, and then the last part, which was kind of a problem which we would not see in the previous step, is that reusability. So somebody said that, it will be easier to build because we have documented system design, right? That is correct. But why will it be easier? It will be easier because you can look at existing system designs and see what already exists basically. So reusing what exists so that we do not have to do it. Like for example, for hard coding, we can look at, okay, config management. If you remember the architecture lecture we had a couple of days, yesterday or day before, we had a diagram which shows all the components that exist in our environment, right? So if you're building something, you should not be building anything that exists. You should only be building what doesn't exist, right? Authentication, you should not be building authentication. We already have an authentication mechanism. You should be leveraging that authentication mechanism, right? So as you start working on it, I'm going to look at what you are submitting from reuse perspective. Each time you pull up things that is already there, I'm going to call you out, okay, did you not look at the design? So you, till now, till the previous sessions, people did not have a big picture of everything that we do. We are starting this differently this session, that we are telling you everything that exists. You have a diagram which shows almost everything that exists. That means that nothing that exists should ever be part of your design as something that you're building. It can be part of your design as something that you are using, but cannot be part of something that you're building, right? You can say that, okay, we will use existing user RBAC system, or we'll use existing config management system, which is hosted here. You cannot say that I am going to create a configuration system to manage my configuration. Okay, clear? Questions till now? Any questions? Good. Okay. Okay. So how are we going to work in this thing, right? So high-level planning and prototyping. So two parts to the project. First part is one-time kind of thing, and the second part is going to be iterative, right? So first part is that you have a high-level requirement. What is a high-level requirement? That means that we have understood a problem statement from some stakeholder. It can be internal, it can be yourself, but you have documented a problem statement that this is the problem you're trying to solve, and that you know how to, you write that down. What is the problem statement you want to solve? What are you trying to achieve, right? And that's an important part too. We have in Craft Studio, yesterday you went to Craft Studio training where you can write requirements, right? So you can upload a document or you can write requirements with the help of AI. That is to document what are you going to build kind of thing, right? And it is very important to write these requirements well, because you are going to give this requirement to AI. If you are not clear in how you're writing the requirement, the AI will not be clear in how it executes the requirement. So you have to know how to write it concisely. The key here is to write requirement in a very specific manner. Don't be vague about it. Don't say good, bad, big, small. Be very, if I need something to handle 5 users per second, don't say I need something to handle a lot of users, for example, right? So be very specific about it kind of thing, right? Then you do a high-level design, which is the picture I just showed you. All the things that you need to build, big picture kind of thing, right? And then after you do the high-level design, somebody said we'll do deployment, right? We will not do deployment at the end. We will do deployment at the beginning. You may find it strange, but we will do the setup and deployment in the beginning. What that means is that you will set up your repositories, from templates or from scratch, whichever way you do, you'll set up your template. You will make sure that you have not written any code in there. It's only a hello world at most, or an empty template, and you figure out the deployment process, whether you are leveraging the existing deployment process that we already have to deploy all the way to production. Now, the key thing to think about is that if you're developing something new, nobody is using it, nobody knows about it, you can deploy all the way to production. There is nothing stopping you, and you can test the whole pipeline, right? Your goal is to make sure that without the complication of your project coming in, you have all the pieces built and deployed. So for example, in the previous page where we had the to-do web, the to-do API, and the to-do database, I would create a repository which has the to-do web application which just says hello world, for example. Or if we have a template, we have the blank template. An API which just has a health endpoint which says okay, nothing else, and an empty database, for example, right? I would deploy this in playtest. I would deploy this in non-prod. I would deploy this in production. I would make sure my URLs are there. I would make sure my web application is talking to my API. My API is talking to my database. I would make sure all of that is there and everything is working, right? Now, why would I do that? Because once you do that, tomorrow, as you change the code in the front end, all you need to do is push and your changes will be visible. So you can show tomorrow that yesterday I was showing hello world, but today I'm showing a real UI. Now I'm showing that this UI, the button works. Now I'm showing that this is kind of working. So if you look at that step, so we will set up the high level design. We will do the deployment. We will prototype the AI, the UI for it. And that's a class tomorrow. You have a class tomorrow for the AI prototype. And you will deploy all of that stuff. You will review the code, you'll deploy, you'll test, and you'll be in production. You'll do this once completely, okay? This is one time, and it has minimal changes, minimal stuff kind of thing in there, right? Once you have tested that it works in production, that means that you will get your application into production tomorrow. In fact, tomorrow's class, whatever you will build, if you attend the class properly, you will have a URL of your app in production. And if you don't follow it, you will not have a URL of your app in production. If you do it correctly, you'll have a playtest, you'll have a non-dev, and you will have a production URL for your URL, right? That's your goal. You need to get to production every day. Now what happens is the real work starts, phase 2, where now you're going to refine. You're going to write detailed requirement one at a time. You are going to design for, like, your high level design may need a more detailed design. For example, if you are building an API, the high level design had the API box. The next level of design says that, okay, I have a get API. Okay, you create the design for the get API. I have a create API. You create the design for the create API. And you don't have to do it all together. Like, there is nothing saying that you need to design all of your APIs all together. If I was doing it, I may start with the get API first, create the get API, create the get API, build the get API, deploy the get API, test the get API, and done, right? Put it all the way to production. Then I will do the create API, deploy the create API, deploy it, get it done, right? The benefit for that is that I am going to production with very small changes incrementally, right? What most people will do, and this is what they will spend 3 days trying to write the design document with all the specs, basically. So they will get nothing into production for the first 3 days. Okay, then they will spend another 3 days trying to get it all into production, right? And then they will show it to me, and then I'll say, okay, the design is not right, and then they will start all over again. So you can spend 2 weeks in this process, or you can get this done in 1 day. Think about it, right? If you wrote the design for a get API or a create API or whatever API, and then you if you show me the design for that, I will take 5 minutes to review that design and approve it. Then you take another 15 minutes with AI to build that API. Then you spend some time with someone to review that code review for that API. Then you deploy it all the way to production. You test it out. It's done end to end, right? You get something done in the first day. So think about it, right? If you are doing work, would you like somebody to recognize your work every day, or would you like a recognition once a week?
Every day.
Every day, right? So think about it. We all are built in such a way that if somebody gives us something good, we feel happy. So, hey, you did a great work. Okay, we feel happy, right? So why not get that instant gratification? And the way to get instant gratification is that don't try to do big things. Most engineers try to do big things, try to do very small things. So your goal through this whole process, and this is where your skill refinement will happen, that you need to find the smallest piece of functionality that can be designed, built, tested, demonstrated independently, right? Like for example, right, if I was building a form, right, okay, I could, the smallest piece I could design was that I could have all the form fields in there, right? And it looks fine, but the button doesn't work, but it looks fine. So I can see something, I can show something, right? That, okay, I have created the form. Does this form look right to the customer? Yes, it looks right to the customer. Tomorrow, the submit button works. Oh, it works. Okay. Yeah. Or on the first day, we have a list of things. Is this list how you want to look at? Yeah, it's how I want it. Today, we can have edit in the list, or today we can have add in the list, right? Incremental progress allows you to get feedback much faster. Remember, somebody said feedback. You don't want feedback in 2 weeks. Why do you want to know in 2 weeks that you failed? Would you like to waste 1 day of your time, or would you like to waste 2 weeks of your time? Think about it, right? Most people want to waste least amount of time. And in 100% of software engineering, you will fail. Because why? You are in the process of listening to someone who is telling you that's what they want, and you are trying to interpret what they said, converting it into requirements, building a software to demonstrate what they asked for. There is no way two people can understand each other so well that what that person said and what you got will be correct in one go, right? It will have to change, it will have to iterate, right? So better to get that validated very quickly, right? Second thing, and this is kind of another important thing which you need to understand, most customers, when they come up with new ideas, they themselves do not know very clearly what they want. It's just an idea in their imagination, right? By putting a concrete face to that in front of them, you are actually helping it shape it in the way that you think that it should work, right? So rather than the customer thinking for 2 weeks and their thinking changing, if they told you something and you showed them something today, now you have influenced the customer thinking to be around what you showed them and what they thought merged together, right? So the next day, whatever they think, they will say, no, let's not do it this way, let's make it a little bit left or a little bit right, basically, right? Whereas if you give it free thinking, they will always think something totally different. But that's not what you said yesterday. You're going to say, but okay, that's what I'm thinking today, right? So the disconnect goes higher and higher the more time that is there between the customer giving your idea and the time they see the idea. Okay, if you want to get a good product out, you want to reduce the time between the ideation and the actual concretization of that idea, right? If you do that, it is very likely that either the idea will revolve right there, or it will develop into how you have conceived that implementation of that idea, right? So that is why it is very important to do this. I have seen a lot of people develop something for months and the product owner telling them that, okay, no, this is not what I want, let's start all over again. And all that does is that you may think that, okay, you worked hard, you should get recognized, but the end of the year, the report will say that, okay, this person, did not get anything done. They will not realize that you did not get anything done because you are working with someone who did not know what they wanted to get done, right? But the point is that both of you are in the same bucket. You need to work together in a way that you guys can understand and get results out, basically. Nobody gets paid for working. Like most people see that, okay, you are working 40 hours a day and you're getting paid for 40 hours a day. You are not getting paid for 40 hours a day. Companies are paying money for outcomes, right? And you will see that as you grow up. Like, for example, as developers, still you are doing what somebody's telling you, you're not thinking about outcome, you're getting paid a salary. But people who are in management or leads or other thing, they get paid many X what you get paid. Why? Because they are not paid for spending time in the office. They are spent for thinking, okay, how is the outcome going to change? What is the difference it's going to make in the world? So you need to start thinking outcomes. And this is the way you can start thinking outcomes. You convert ideas into reality very quickly. and fail fast or move forward fast, whichever way, doesn't matter, but you decide fast. You do not waste time. Time is money. You do not waste time in a software development lifecycle if you do it this way. Okay, clear on this part? We're going to go through this is something, as I said, this is the most important part of it, because I am going to evaluate you on the following of this process on everything that you do. Like there is no, like for example, one day you start on a project and you show me local host instead of showing the deployed URL. I'm going to ask you, did you not do the deployment kind of thing? Okay, I'm going to look for the mistakes you make on this process. Like all in this next 3 months, I'm only going to look for mistakes. I'm not going to look at what error is wrong in the code and all of that stuff. I really don't care about the code, right? I don't even care if the code is right. I don't care if the code is wrong, right? However, I'm going to ask you, okay, where is the high level design? Where is the setup? When did you deploy the setup? When did you do the deployment? Where is the prototype? Where did you get it confirmed? Where is the design review? Where is the code review? Where is the this thing basically? Where is the test case? Where is all of this thing? Each of these words has an artifact, and if the artifact is not present, it will not count. So you cannot tell me that you did something without an artifact. For example, high level requirements, right? If you do not have the requirement written out and it is written before you actually did coding, it doesn't count. Okay, if you do not have the high level design documented, it doesn't count. If the design is not reviewed, it doesn't count. Okay, if you have not deployed hello world and shown hello world, it doesn't count, right? If you have not written the test case, you cannot say you tested. You have to do it. First of all, you have to have a test case, right? Secondly, you need to have executed the test case, which also has a record, right? We have a system. We have a training session for you on test case management and test case execution. So you will go through that. And if you do not use those systems, it doesn't count. Any statement you will make without an artifact will mean that, okay, you went to watch a movie and you're trying to fake it out here. Okay, I will assume that if you do not show an artifact, you went to see a movie, right? If you said you coded and there is no PR, you went to see a movie. If you say you wrote a test, you tested and there is no test case and no execution report, you went to see a movie. Okay, when you hear me call out that did you go to see a movie, that means that you presented something without an artifact. Okay, every activity that you do has an artifact. Okay, keep that in your mind. You should think of what is the artifact, what will I show for it. Basically, documentation has an artifact, coding has an artifact, testing has an artifact, everything has an artifact. So that's kind of very important. Okay, design consideration. So what do you consider when you're doing design? The tech stack that is there. Every organization has its own tech stack. It is very important to understand what are parts of the tech stack, and irrespective of your preconceived notions of what a good stack or a bad stack or popular stack or whatever it is, your goal is to work within the tech stack while, like as I said, I encourage you to thinking while suggesting that, okay, we are using this tech stack, why don't we consider using that, and suggesting that and working with your team to figure out if that makes sense and then incorporating it. But the team staying within the tech stack is very important, because staying within the stack means that there is standardized within the organization and allows people to work across different projects. Basically, if one person uses one proprietary stack, if the whole company is React and one person uses Vue, what happens when the Vue program fails kind of thing? No support, right? So the stack standardization is very, very, very important, right? Reusability. Now, the best engineer is one who does the least amount of coding, right? This is true in all professions. Like, for example, you will notice that when they are building dams, right? India has a lot of dams kind of thing. US also has a lot of dams. You will see that they don't build dams in random places. They will look, okay, there's a mountain on this side, there's a mountain on this side, we will build the wall and the dam is there, right? They will not say, let's take a very open ground, let's build left wall, right wall, back wall, and that's the dam, right? Nobody does it that way, right? You will see that all dams are built with some natural stuff and the bridge which is in between. That is the same principle of software development. You look for things that are there and you build whatever is necessary. The engineer who can have the maximum impact with the least amount of code, least amount of change, least amount of build is the best engineer involved. Why? Because first of all, they spend less time, they spend less money, and they got the work done. Why not, right? somebody who's spending a lot of time doing things which are already there, really, like, why are they doing it, kind of thing. So always focus on the gaps that are there instead of trying to build everything from scratch, which means that you need to understand your ecosystem to be really productive, right? Security, most people and engineers don't think about security. It comes as an afterthought. When you're starting to work on things, start thinking about what is the security. Do we need to protect this data? How is the user going to authenticate? Do we need to encrypt this data? Think about it, make that as a design consideration. If you're not sure, ask your architect, but have the questions. You asking the question shows that, okay, you are thinking about it, right? So very important. Most applications which fail because of security and authorizations are one where security and authorization is added at the end after the fact, then versus during the build process itself. If you think about anything that you do in Humanize IQ, you need to make sure that everything that you do has a permission associated with it. We have the ability of giving permission for everything. So, okay, there's an edit button. Make sure that the edit button is coded with a permission. Okay, there is a view button. Make sure that the view button is coded with a permission. Why? Because if you build the application without permission and then tomorrow says I need permission, you need to change the code everywhere out there. So assume that the permission will be needed for everything. So put a permission code always there. And you can make sure that there is a person who has been given all the permissions. That is easy because that doesn't require you to change the code, right? So it's always better to code your application the right way with security and authorization in there so that you do not have to go back and fix it. Okay, very, very important. Configuration and logging. So you will find that no matter how good of a developer you or the AI is, there are going to be problems that are going to happen and you need to be able to debug it, right? So focus on making sure that you have instrumented your application to have logs of things. For example, if you are making a HTTP call, a call to a web service, right? Make sure that you log the URL that has been called. Make sure that you log the headers that are being used. Make sure you are logging hidden credentials. For example, the first 3 letters of the credentials, so that don't log the whole credential, never log whole credentials, but you can log the first 3 letters to know that, okay, is it the right credential or not? Log the payload that is going in, log the error code which is coming in. Why? Because you deploy your code, it doesn't work in production, you will again have to change the code to put those logs in there because it will fail. It is guaranteed to fail. You will not get it done right anyway. Where did my thing go? Where did my thing go? Where was my presentation? Yeah, it's okay. So definitely log so that you can track that configuration, make sure that you can debug the problems, find out what's going on and all of those things, right? Secondly, think about monitoring. If in our company, we are not building projects. We do not build small projects. Almost everything that we build for enterprise scale. I unfortunately am very bad at building projects. Like I know in your colleges, you did projects which kind of you develop and deployed. I am very bad at projects because last 25 years I worked in a company where we always had millions of users coming in. So everything that I build is kind of enterprise scale. Even if it is for 1 user, it is enterprise scale. Even if it's a million user, it's enterprise scale. That means that you need to think about monitoring it. What will happen when it fails? When the user comes, you're not watching one. So you build monitoring in there. You tell the DevOps person that, okay, this application is running, let's set up monitoring so that if the response time is low, I want to get an alert. If there are errors, I want to get an alert. Think about what could fail and set up monitoring for that. We have monitoring capability, right? The performance and scalability. What will happen if 2 users use the system? What will happen if 1,000 users use the system? We need to think about scalability in terms of, do we need to cache something? We need to add more servers. We need to have more threads, whatever it is. Test. Just don't assume that the application that you're building, you are the only user of the application. You are not doing projects. So first thing you have to get out in your mind. In fact, many of your resume has a section called projects, right? We do not do projects here. Okay, if you did projects in your lifetime in other companies or whatever, we do not do projects here, right? Projects are for kids, school kids. Here we build enterprise application which scale for multiple users. So you need to think about how to scale the application. There will be problem, right? Scaling and reliability are 2 different things. What's the difference between scaling and reliability? Can somebody tell me what is scaling and what is reliability? Raise of hands. Anybody know scalability, reliability? They mean the same thing, different things? Yes, Ishan.
Scaling is basically how well can we expand the system, and reliability is how much can we depend on the system, like how safe is it is.
Safety is not. Safety will go somewhere else, but scalability is about how can we expand the system, how many users can it take, how many processes can it run. It's not always about users, it can be about processes, transactions, all of that stuff. And reliability is how dependable it is. Is it going to be available all the time? Is it going to be available some of the time, right? Both require different considerations. Like, for example, scalability requires that your code have no bottlenecks, for example. Reliability may require that, okay, you are going to maintain, you have to maintain something. Should we have two servers while one is maintained, other is not maintained? So you need to think about that, right? Lot of these things people at your level don't do because there are architects and people doing it. But I want you to learn this today, and remember, while doing everything, put this mindset out there, because remember, you are not trying to compete for a job for a fresher. You're trying to compete for a job which is a 1-year experience person who can build scalable, reliable enterprise scale applications. So get these questions in your mind. Ask this: how will it scale out? At the very least, maybe there's somebody has already done it, but you need to ask that question. You need to get the habit of asking that question, kind of thing, right? If you get in the habit of asking that question when you're developing, when you are being interviewed, you will get into the habit of answering, yeah, I built an application which could scale up and was also very reliable, had a 24/7 uptime with 100.5 zeros of SLA, right? You will hear in the industry, like, in fact, if you read almost everywhere in the industry, they talk about 99.59s kind of thing. Have you heard about the 99.59s SLA kind of thing? What that means is that your system is going to be up and running for the whole time with a 15 minutes of downtime for the whole year, right? So if your application is down for more than 15 minutes in the whole year, you lose that 99.59s basically, right? So think about it, is difficult to do, right? Things will go wrong, things will fail, kind of thing, right? Now, my strength is not 99.59s. I don't like 99.59s. And in my company right now, we are less than 99.59s. My strength is 100.50s, right? Which means that your application never goes down. I built a system where application never goes down, right? It's not that we don't maintain it, not that we don't deploy, but we make sure that it doesn't go down. It requires thinking about it. Like, for example, in WebMD, we solve this problem by saying, okay, we have multiple data centers. So we will make sure that anything customer facing is always 100% up. That means that our website is always up. If we are deploying something, we will deploy to the East Coast while moving all the traffic to the West Coast. And when we are tested the East Coast up, we will move all the traffic to the East Coast and deploy to the West Coast, kind of thing, right? So that means that each data center is, both the data center do not go down at the same time. They go down one at a time while the other data center handles all the traffic, right? So for the end user, they do not realize that something is happening. They just know that, okay, it is always up, right? Many companies do active passive, for example, where they have two data centers, but only one is active at a given time, which means that when this fails, they will switch over to the other one. That takes around 5 minutes or a couple of minutes. You still have a 5-minute downtime. But if you run both active, you never have a downtime. If you have multiple 3 or 4 data centers, you never have to go down, kind of thing. And that's kind of, you need to think about it. It doesn't happen. And you should only do it if it makes sense. For example, in WebMD, we did not do it for a long time because the revenue we were getting was not big enough to justify the 100% uptime, right? But then we realized that, okay, one time we had a downtime, and that one day of downtime or whatever it was cost us few $1,000,000, right? So we decided that if it costs us few $1,000,000, we can spend $100,000 in building a system which is always up, right? And so we spend the money. So again, the question is that it's not always required, but you need to think about it. That is your system, how reliable is it? Is it 100% reliable system? Is it a system which only works 9 to 5? It is perfectly okay, right? Like, for example, if you know that you have people who only come between 9 a.m. and 5 p.m. Eastern Standard Time, you really don't need a system which runs 24/7 at high reliability, right? You only need something between 9 to 5. So you need to know what your customer is, what they need, and see if it is reliable for that scenario, scalable for that scenario. You don't want to create a system for 1,000,000 users when you will only have 10 users. But the question is that you need to think about performance. You need to ask the questions. that how many users are going to be there, and is the system scalable and reliable, and what are the solutions for scalability and reliability. The last part, this is the part which almost 99.9 engineers do not get, only 0.1% engineers get, and those 0.1% engineers are the CTOs and the, people keep bothering me. Okay, those 1% engineer, 1.1% engineers are the people at the top level who are making the decisions about everything, right? However, think about it. If you start thinking about cost as today, you are automatically on the way that you are competing with the CTO for that job. You are ready. You're talking about cost. You're talking about value. You're talking about ROI at a very early stage in your careers, whereas 10 years down the lane, I started talking about ROI pretty much maybe 12 to 15 years into my career, maybe 12 years into my career, right? For the first 12 years of my career, I was just writing code. My boss was telling me, and he was saying, Raj, you did this, you get 5% raise, you did this, you get 10% raise, this is your bonus. That's how I was doing it, right? But after maybe around 12 to 14 years, I spent trying to understand that, okay, I am spending this much time, I am making the company this much money, this is costing this much, I am not getting paid enough, and I can go to my boss, I need more money, otherwise I'm going to another company which is going to pay me for my ROI. So, but the only person who can have that conversation is somebody who understands the cost efficiency. How much does it cost to make it? And cost is multiple things. Cost is the time you have spent. Cost is the infrastructure that you are using. Cost is the AI you are using. With AI, cost efficiency has become very, very, very important. If you have not been watching the news, Microsoft just this month said that none of the company will be using Claude Code anymore because they are spending too much money on AI tokens, kind of thing, right? So why? Because they did not plan to use it. They did not think about it. They thought that tokens are free. There's a free subscription, unlimited subscription. It is not free. Unlike traditional software, where we are just having one server and doing whatever, here every word you send and every word you get is paid, right? So costs are coming in. Uber also released the news 2 days back that they spent $500 million, 500,000, $500 million in 1 month, which was their whole year's AI budget, because they did not have the controls in place. Okay, so think about it. With AI, you can spend, suddenly you make a mistake in your code, it can result in $100 bill versus a 10-cent bill, right? So you need to be much more conscious. Like, AI is going to require us to become much more conscious of how we are coding. For example, right, if you have a folder where all 20 repositories are there, and you tell AI to analyze it, right? You may get a bill for $100, and we are going to question you what kind of thing you are doing with all the repositories being sent to the AI at the same time, right? Because what are we telling you is that you need to take small problems, send small things to AI, get the result back, make small changes. It will cost less than a cent, right? Whereas you can, the top Claude models like Opus and this thing, you can literally end up spending $5 a minute, basically, like $5 a minute kind of thing. You can imagine how much that would be, kind of thing. It would exceed all your internship. Like, you guys are getting, most of the people in India, internship, you're getting $100 maybe. Okay, you can spend $100 in what, 20 minutes basically, right? 20 minutes of Claude can spend $100. Think about it, right? So do you think that people will prefer you to do that? They will not think that you're efficient engineers. So the future AI engineers efficiency is going to come down that, okay, which engineer can get the maximum work done using the least amount of AI in the shortest possible time, right? Think about that sentence for a moment, right? Previously, it was about going to office, writing code. Nobody cared, right? Now we care about outcomes. What is the result you got? How long did it take to get the result, right? Time to market. How much did it cost to get the result, right? All things are important, right? And the most efficient engineer is the maximum impact, lowest cost, lowest time, best quality, right? Okay. Hold on. Is my browser? Okay, so cost efficiency is very important, and I want you to start thinking about it day one. You should always plan for your project that this is going to be, if my application run, this is what the cost is going to be, this is the expected cost. You may be wrong, it is okay, but at least start planning for it. Think about that. Are we recording the transactions, right? Every time you do something, there's one question I'm going to look at it. What is the KPI for your application? So you said, okay, you worked on this feature. My question is to go to you. Why did you work on the feature? And your answer, and this is, I'm telling you what your answer is going to be. Even though I'm telling you, you're still going to answer this way. Basically, I hope you don't. You're going to tell me that I did this because Raj asked me to. I did this because Anubha asked me to. I did this because Sahana asked me to. I did this because Kesan asked me to. This is going to be your answer, even though I'm telling you that should not be the answer. Your answer should be that, okay, I developed this feature because 20 users in our organization are facing this problem, and I'm trying to solve that problem for them. Right? That is the impact, right? When you are doing something task-based, you are robots who are following instructions. When you're doing something based on impact, you are engineers, you're thinking of what you are doing and how much does it cost to do it, right? I would ask, okay, 20 users are impacted. How much time are they losing? Oh, they're losing, 5 minutes a day. Is it worth it to fix? I don't know. Like, is it costing you more than that to fix? Like 5 minutes a day, 20 developers, okay, 100 minutes. What is the cost of 100 minutes, right? If you assume, okay, what your salary, this is what 100 minutes of salary cost. Like, developing this solution requires you to spend $500. Should we spend? Should we not spend? Do we have something better to do? And that's the kind of decision making you need to think. And that's kind of important for design, right? That being said, what is the perfect design? So these are questions for you. So I want you to answer, and then we'll go to the next step. So what is the perfect design? How can we get the perfect design? How long will it take? What is the prerequisite for a perfect solution? Raise of hands, of course. These are not rhetorical questions. I need you to answer.
Perfect design we can get when the developer and the user collaborate properly and understand the idea.
Okay.
Discuss.
Okay. What else? I'm not saying right or wrong. I'm just, there are no right and wrong answers to these questions, of course, right? So I want to hear opinion, because then I'm going to tell you what my thinking is, but I want to get your opinions. So what is the perfect design? Yes, Tasneem.
The perfect design, I think, is it is the requirement, whatever the requirements the user is asking, it should be in our product. So I think that's the perfect design.
Okay. What? Who else? Yes, Ishan.
I think the steps that should be taken in order to get to the perfect solution should be first, we need to keep it clear, as someone said before, that we should be able to understand what the user needs, and then we need to follow the perfect steps of the software development lifecycle in order to get the perfect solution.
Okay. Who else?
So I think that design should meet the business requirement, and also it should be easy to maintain and scalable. So that's what perfect design is.
Okay. What else? Yes, Khyati.
A perfect solution would be where we have clear requirements, precisely what we need for how many person and exactly for in how much time. Everything should be precisely mentioned, and that would be and according to that, if we do build something, that is a perfect solution. If we have everything in a systematic order and a proper.
Got it. So, Khyati, you need to get better at learning how to not repeat yourself 3 times in 3 different ways. Okay. You're saying the same thing 3 ways. Like, you got your point across. Try to compose yourself. Once is good enough. Right. Gravit.
How does it suit the budget of the user financially?
Okay. Anyone else? Ankit, you did not say anything, so.
I think the perfect design involves high level design, everything that was involved in the AI SDLC, and it includes it calls on what we learned about cost efficiency and everything of that sort.
Okay. Second question, very important. So everybody, I want, yes, Anshuman, you want to say something? Yeah, go ahead.
The prerequisites can be a clear and complete requirements with continuous user feedback.
Okay. Okay.
It
Second
might be a
Second question, everybody, I want a number from everybody, right? How long will it take for a perfect design kind of thing? So everybody, a number basically. So for example, if we are trying to build a to-do application, like simple to-do application, I'm sure everybody has done a project in college for to-do application, a to-do list kind of thing, right? So the perfect to-do list, right? How long do you think it will take to get the design for a perfect to-do list? Everybody needs to have a number in place. So
Half a
design,
day.
we're not even talking building, we're just talking about the design basically.
It's less than half a day.
Okay. Anshuman.
I don't have a number, but I would say it depends on the complexity, how deep we go.
Okay. So let me give you a different perspective. First of all, my view, and you are free to disagree with it, and this is kind of why I said you need to have a critical mindset. There is no possibility to have a perfect design. A perfect design is impossible, right? I'll tell you why. All of you watch cooking shows on television. Almost everybody is familiar with cooking shows on television. What Sanjeev Kapoor is still the cook, or what? Who is the most recent cook in India now? Who is the top cook in India now? Who's the chef? Top chef? Anybody? Okay, let's go with Sanjeev Kapoor, right? Sanjeev Kapoor shows you the perfect recipe on television, right? The recipe is the design, right? He also does the whole recipe in front of you, right? Do you think that you can replicate that recipe identically at your home and get the same taste? No, right? Like it's impossible, right? Same thing goes for software, because somebody said correctly that we need to have perfect requirements. So, okay, can you get perfect requirement? Can you perfectly convey? The whole thing of human expression is a very qualitative expression. We try to do the best way to express our words in a way that the person we are speaking to understands. So it is impossible to express a requirement perfectly. A perfect requirement is one which can be expressed in zeros and ones, right? Like, okay, it's pure mathematical. Unless it is mathematical, it is not perfect. There is a qualitative aspect to it. And that qualitative aspect prevents the person who is understanding also to apply qualitative analysis to it. And so the design which will come up will be a qualitative design. So perfect design is impossible, and it will take an infinite amount of time to get a perfect design. And most people who try to get a perfect design and a perfect product are people who do not get anything done, right? What you need to go for, and that's what I was trying to tell you, this was a trick question. Like in the previous sessions, I told you that we want to get instant feedback. Why? Because requirement is not clear. We take the requirement, we put something in there, we are influencing that person's requirement to become this thing, right? So you are actually trying to make the requirement perfect by showing them the product, and in that sense you're trying to get to what the user needs, and in the best or smallest possible time that is possible. So do not try to get for perfect design. Do not try to get perfect code. Code which is good enough, code which works simple is what you want to, because you want to iteratively get better. We are not trying to do where we take 10 years to build the perfect product. We are trying to do something that we can get done in a day or less, and then improve it next day. And we stop at the time when we feel that the product is good enough and we don't need to develop any further. Okay, so we will not spend the time to build a perfect product, because nobody in the world can afford a perfect product kind of thing. I can tell you, like, even if you build a house kind of thing, or people who build houses, you can do the best possible something. Somebody is going to find a fault in somewhere in that house basically, and it will not be perfect. You will take compromise because of cost or whatever it is basically, and that is okay kind of thing. Nobody needs perfection. Okay, perfection is not achievable. In fact, if you achieve perfection, there is nothing to be done. So in this world, other than nature, nothing is perfect kind of thing. And even nature is not perfect at times kind of thing. So don't spend your time trying to find the perfect solution. Find the best possible solution in the shortest possible time, in the lowest possible cost that you can get to. Okay. So a perfect solution, not possible. Why? Because requirements are not perfect. Functionality matters more than things looking nice. So as you're building things, first focus on making it work, then try to make it look nice. Lot of people try to do the same thing. I have seen people, students, who will try to spend 3 days trying to show me a perfect demo, whereas the person who showed me something working on the first day got credit for it. The person who showed me something which looks better the second day got credit. By the third day, the person is launched, whereas the first person showed me something on the third day and we said, okay, start all over again kind of thing, right? So iterative improvement, functional things which are good enough to demonstrate the concept, and then improve to the extent that is necessary. Don't spend your time on it. You're not born to write code. You're born to solve problems in the world. So solving problems is functional, not beautiful kind of thing, right? So that's kind of what you want to focus on. And iterative improvement only to the extent that it needs to be improved, not to the point of perfection, right? So look at it and then always get your feedback from the customer so that you know that is that what they want. Because the thing is that you are developing software, somebody's paying for it. So the way I look at it, that you have a choice, right? In this 3-month internship, you can decide that I actually encourage people to learn. So some of you may decide that, okay, I will only spend the time learning. I'm okay with that. I'm not going to stop you from doing that, because if you're learning, you're showing me something you have learned, I will appreciate you, I will recognize you, but I will not pay you. Why? Because I am paying for results, right? So for example, you are getting a stipend or a salary or whatever, you're learning, fine, we are paid. You produce something which I can sell and the customer pays, I should pay you more for it, right? That's kind of how it works. So always think about, like most companies have today, kind of they pay for presence. You are in the office, you get paid basically, right? However, with AI, it is changing. You are going to get paid more and more for outcome. In the future, we may be that, okay, people do not have jobs. You just have your agents and there are tasks out there. You complete the task, you get paid for the task. So you can ability to do more tasks, less tasks, or whatever kind of thing, right? So outcomes are what is important, right? So try to get outcomes, try to have impact versus keeping on working. People who are working, and you will see it among yourself, right? In the stand-up, you will say, I am working on this, I am working on this, I am working on this. Some people will use this word very commonly, and some of you will say that, okay, I did this, this is what is working, you can use it today, right? And that's the difference. I am working on it, this will get one thing done in a week. The person who's doing a demo is getting 5 things done in a week. And the person doing 5 things, if I said, okay, you get paid a 50 cents for everything that you do, you'll find that the person who gets done one thing in a week will get 50 cents. Person who gets 5 things will get $2.50. Would you prefer $2.50 or would you prefer 50 cents? Think about it, right? So here at Humanize IQ, we are very focused on outcomes for our employees and for our interns. So you will be recognized on your progress, not based on the time you spend. If you can get the whole work done in 2 hours, that's great. You tell me that, Raj, whatever you're teaching, we learned everything, I have done everything, and I spent 6 hours watching a movie because, you know, that was the best use I could find out. I'm okay with it. That's perfectly okay with me. But the point is that you get paid for outcomes, not for being busy. I don't need you to be busy. I need you to change the world. I need you to impact, basically. So that can only happen if you produce something, take it to the customer. Is this what you want? No, I don't want this. You change quickly, get them what you want, and you're having impact. If you just keeping doing working, you're not having impact because you're not asking the customer what they need. So think about the customer. Our pillars of our company are focused on that, and that is why I'm telling you this. We want to focus on making sure that everything that we do results impacts on employee. The impact on employee or student is that your mind is growing, you are making money. That's the impact on you. Impact on customer is getting something of value. Impact on customer. So social impact, almost everything that we do will be not only sold to customers, but will be given out to end users. So, and for free in cases like we are trying to make sure that people in India, for example, people who cannot afford AI. We can give AI tools to them for free. So you will be developing tools which you will be selling to corporate customers, but giving for free to people who can't afford. So you're having an impact on society, right? The company makes money. So that means that you are okay. So company makes money, investors make money. So everything that we do has to have that impact. Now, most companies operate this way, right? But I'm telling you, if you have your senior people in your homes, other siblings, other friends, you will talk to them. You will hear frustrations from them in their job. I am not getting enough of a raise. Okay, that's the most common frustration, right? I am not getting promoted. Second frustration. I am being stagnant, right? The point is that most people in their jobs are expecting their manager to figure out what is the impact of their work. Their managers are getting paid well. They are not getting paid well, and they are blaming everything else, right? The point here is that you need to understand what is the impact of what you do. And if your impact is to just learn and not make impact in society, that's your choice you have to make, but you need to make that conscious choice. Okay. Here in our company, if you work with our company, whether it is E-team or whether it is Humanize IQ, none of you can expect a raise of 10% or a 0% kind of thing, irrespective of how long you are here. Okay, we will not give you that raise. However, you may get a promotion or a raise anytime you make an impact, right? Why? Because you are having an impact on the company, you should get rewarded for it, right? And that's the lesson you need to learn, that most companies, you learn this lesson 15 years down chain, but if you learn it in the beginning, you will always be able to go to your manager and say that I am making impact, why am I not getting? You get the right to question your manager the moment you start making impact and understand the impact. Most people do not understand the impact they make. Okay, so very important to get feedback from the customer. Customer will know about your impact and will talk about it too. Okay, what are the design tools that we have? So we will write design in markdown format. So you should get familiar with what markdown format is. It is a text format which allows formatting and is easy for AI to understand and easy for presentation and other things, basically, right? We will use diagramming tool, mermaid diagrams. Mermaid diagram is a markdown way of doing diagrams. It allows you to do diagrams as text, and it renders correctly in a markdown renderer. Very powerful and has become very popular in the AI world. We can also do diagrams in draw.io. You will have to put it as pictures, which is okay kind of thing. It's good to start out with drawing diagrams with draw.io. Secure Chat, which you had a session with, has the ability to help you write the markdown or write the diagram properly. However, as you're doing, first step is to know how to do these diagrams yourself. So the diagram types you need to know very well how to do is HLD diagram and sequence diagram, ERD diagrams, data flow diagram, and logic mapping kind of thing, like for example flow charts and stuff. Once you are very good with this thing, then having AI do it for you is not a problem, but till you're good at it, do it yourself, because if you present a design with these things, I am going to interview deeply on these diagrams, basically. Okay, so use AI to learn how to do this well. If you did not do this diagram, if you skip that book in your college first year, please open the book. All of these diagram types you need to use. Not all will be there in all diagram, but it will be there in some of them, will be there in all of them, basically. Okay. For prototyping, we will not do Photoshops or mockups. We will directly do prototypes in vibe coding tools like Google AI Studio, Lovable, or whatever it may be. And that way we can quickly validate with the end user that is that what they want. But when you're working with prototypes, make sure that you're not hard coding any data. You're going to do the prototype tomorrow. You're going to get exercises for hope. Each of you is going to get a different exercise. So that means that we will evaluate you on your work, on your independent work. But one of the first things on tomorrow when you get the assignment is that you're going to write a vibe code where the data is inline in the HTML. Okay, don't do that. Make sure that you instruct your AI that all data used by your application is in JSON file. Come up with a structured JSON file. You're not integrating with any API tomorrow. You're writing static content code, but you need to still follow structured way where the data is coming in JSON format and all of that stuff, basically, right? So JSON is very important. So Markdown, very important. JSON, very important. Mermaid, very important. You tell your AI to create mock data in JSON format. For example, if you're doing a list of to-dos, you can say that, okay, put mock data in list.json, which you can use in your front end, for example, instead of the HTML having task 1, task 2, task 3. Why? Because later on you can replace that JSON file with an API call and you'll be done, kind of thing, right? That's kind of where you want to be. So this is about learning how to do UX without having backend there. Then when you do API design, we will use Swagger documentation, Open API documentation, and for every API, we need to know what kind of method, what kind of input, and what kind of output is required. So we'll document that as part of the design. You will have a class on that, and we'll go into detail in that basically. For orchestrations, where we will use n8n or Diffie, we can do flowcharts and mermaid diagrams to show that, or we can directly do it in n8n. And that is also fine basically, but it is good always to document it in a flowchart and stuff, which makes it easier. So these are tools that we will have, and we should use them to get the best outcome. These are tools which are used in the AI world, because the Swagger documentation will serve as input to the AI. So you need to make sure that you follow that, don't follow other things. Open API is going to be used for the AI. Prototypes, the JSON data structure is going to be used for API. The mock data will allow you to work with getting feedback from the user without building the whole product basically, right? So very important kind of thing. And once you get approval, you will spend less time integrating with API. If you have mock data, if you have inline code, you will spend more data with it basically, right? Other design considerations, make sure that you use CI/CD from day one. I am one of those people who likes to first build, deploy, then write code, right? So build is step number 1 for me, right? So deploy your template first, test hello world, end-to-end testing, make sure that everything is there. Then you start writing your code. You never write. People who write code are always kind of, for me on a scale, my respect for an engineer, somebody who writes code, I don't respect that engineer. Somebody who deploys first, I respect that engineer basically, because is a problem. Writing code, you're a coder. You don't fall in the same bucket as me. So start doing deployment, those things first. Coding is going to be done by AI. Configuration, we talked about hard coding. Do not hard code. We have config manager. We should make sure do not commit any secrets into source code basically. I see secrets into source code. It's like putting your password for everybody to read. You do not do that. You do not put it in there. Use config managers for secrets management kind of thing. Use mock data wherever possible. Don't hard code basically, right? Like, so if you're doing a to-do list, don't hard code the data, task 1, task 2, put it in a JSON file so that you can change it kind of thing. You can change the data. Always separate data from front end, right? Maintenance, make sure that you know how to do debugging, both front end debugging, back end debugging, through logging, through breakpoints, add logging statement, monitoring. Iterative building, as I said, try to build in layers. So build it, working code, improve it. Modular architecture, so try to do small pieces which can be reused across the world. So for example, if you have URL routing, routes should be in separate places, business logic should be in separate place, front end HTML like code and logic should never be in the same file. Again, when you ask AI is not going to follow this. AI is going to get a working product where everything is in one file. You need to instruct AI saying that, okay, I want presentation code in a TSX file, for example, and any front-end logic in a .ts file, any data in a JSON file. So you need to be able to give these instructions in your prompt so that the AI is going to do. Your AI is not magically going to do it right. If you do not give this instruction, you are vibe coding. If you give these kind of instructions on best practices, or no file is more than 200 lines or 150 lines, then you are doing the engineering SDLC way, right? And that's kind of what we are going to observe how you do it, and that will determine the kind of projects you're going to place in, right? So if you do crappy work, that's kind of what I tell it, like random vibe coding, you will get placed into those testing, debugging, and those jobs basically. If you do very good AI SDLC work, you will get placed on top projects like voice and other things basically. So you need to earn your spot in the job. Your resume doesn't earn you the spot, your experience doesn't earn you the spot. Your adherence to process and the way you work, you demonstrate your work ethics, will earn you a spot on the top project. You want to work on OpenClaw, you need to earn that, okay, you are systematic enough to be working on that. You don't demonstrate that, you don't get it just because you're here. Okay. Let's see. Design checklist, right? So you can do this every time you're doing something. Make sure you do a high-level design diagram, discuss and review with an architect. Set up your repository, builds and deployment. See, I did not write about code. Do detailed requirement, design and review with the architect. Write the test cases. Like I'm even asking you to write the test cases using AI. Then write code using AI and then build and test. So think about it, right? Writing code is number 5. I can with 100% confidence tell you that each of you during your engineering, writing code is step number 1 and everything else is step number whatever basically you don't do, right? But here writing code is step number 5. The person who writes code in step number 5, top engineer for me basically. The person who writes code before step number 5, as each level goes up, that's the level of your code basically. Okay, so start in this order and you will do very well in this interview. Just by following this process, your productivity, your AI predictability will keep on increasing kind of thing. Don't follow this process, you will find that you're going to blame AI, you're going to blame people, you're going to blame everybody else other than yourself, but you will not blame yourself for not following the process. So follow the process. Checklist is given, you have the slides, and make sure that you do it right. Okay, that's my last slide. So any questions? I have my other meeting, so I will give you 2 minutes to ask questions. Of course, you can reach out to me afterwards or in my office time tomorrow to have more questions. But any questions? Everyone understand what the process is? Do you think you can apply it? Remember it? Okay, we'll see. Okay, we have the stand up. I need to drop off, so we'll meet there and then I'll see you guys again. Please follow this. Next week onwards, you will be graded on these things. Basically, this week is kind of you getting familiar. From tomorrow, you will get invited to the 6 a.m. stand up where you will talk about what you're planning and you will tell just like everybody else. And at the end of the day, you will show that your planning is coming. So you will get invitation to the 6 a.m. planning meeting tomorrow with the rest of the team, and you will see them. I would say this week observe, and if you feel comfortable, start doing it. From Monday onwards, you are expected to tell your plan, and then in the end of the day, you say that you execute on the plan. So I know some of you have already started writing tasks. That is great, but we'll look at your planning process and you declaring upfront that this is what I will do and this is what you've done, kind of thing. Okay, cool. Thank you, guys.